we will check, okay, whether the email addresses have a valid format or not, right? So this email address column has these values and one of them is invalid, right? There's third email address in third row, right? So let's print only these two columns, full name and email address. So to print these two columns, okay, we can use df and specify column names here. Okay, we want to print full name and email address. Run this cell, and now we have, okay, full name values and email address values, right? Now, first of all, create a pattern. Okay, we always use regular expression pattern, okay, for validating email address, okay, to validate whether email address is valid or not. So here, so we can declare a variable email pattern equals to, and because now we are going to create a regular expression, so we can use R here. Okay, now in double quotes, okay, we can construct a regular expression, okay, to validate email address values. And we want to check, okay, values as whole, okay, in its entirety. So in that case, we can use caret and dollar. So this caret denotes the beginning of value and this dollar denotes the ending of value, right? And within starting and ending, okay, now we can specify valid characters. Okay, so here we can use square brackets and backslash s. This is used for space. Then at the rate not. Here we can use, for not we can use caret. Okay, backslash s at the rate plus means one or more occurrences. Then again at the rate, and so this at the rate is actually this at the rate, this at the rate, and then after this, after this at the rate, not space, and then at the rate again. So not means space is not allowed, at the rate is not allowed, right? After at the rate, and again we can use plus one or more occurrences. Then we can use a dot. Okay, so this dot means .com, this .com. Okay, then dot, and after dot, then again, okay, space is not allowed, so you can use caret at the rate, space is not allowed, at the rate is not allowed, multiple occurrences, right? Okay, so we have constructed a regular expression. This is very basic regular expression. Okay, we can construct a complex regular expression, okay, to validate email address properly. And then, okay, let's run this cell. Okay, so this email pattern, okay, this regular expression has been created, and then we can use this email address, okay, to validate values in this column. So to validate values in this column, what we can do is df specify the column name here. So column name is email address in data frame. So here we are selecting a column, right? And then dot str, and on this str we can call a match function, right? And then pass this email pattern, okay. So we want this email pattern to be used, okay, for matching values in email address column. So this df of email address will select this column, and then this match will match this regular expression, okay, with every value, right? And then na equals to false. Okay, I'll explain actually what this parameter is. This is optional actually. Okay, and you can set it to scalar value also. So this is used to fill values for missing values. So if there are missing values, if there are na, okay, you can set it to a value. It means wherever is na in this column, okay, that na will get replaced, okay, with the specified value. So you can specify a value also here, right? So the default depends on the data type of the array. So for the strd type, so currently this is string type, right? So for the str data type, we use false. And for object data type, okay, numpy.nan is used, nan. And for the nullable string type, okay, pandas.na is used, right? So for str, we are using na equal to false. And then store this result, okay, in valid email. Valid email. So valid emails, okay, where this email pattern will match these values, or these values, okay, pass all the values which will pass this email pattern, okay, will be returned, right, and will be stored in will be assigned to valid email. Run this cell. Okay, we have executed this cell also, and now, okay, we can use loc function. Okay, so loc function, and we can exclude the email addresses which are not there in valid email, right? So all the email addresses which are not there in valid email are invalid email addresses, right? So here we can use df dot lock, and within square brackets valid email, use tilde symbol, not of valid email, means if there is any value which is not in valid email, it means that is invalid. Okay, which column? Now specify the column. An email address column. An email address column, right? So set if there is any value in this column, okay, which is not existing in valid email, set that value to, we can set that to pd.na, right? So every value in this column, okay, which is not there in valid email, okay, will be replaced with pd.na. This is what we are doing here, right? Run this cell. Cell executed successfully, right? And then in next step, what we can do is we can print full name and email address again. Run this cell. And if you see here, I showed you invalid email address in third row. carol.lee@example.com is not there, right? So this is invalid email address, and now invalid email address has been replaced with na, right? This is pdna, okay, pandas na. So this is very simple email validation step. Okay, so here this regular expression is very simple. Okay, this step checks whether each email has the basic structure of an email address. So here we are checking what? Structure, the structure which we specified here in this cell, right? If an email is invalid, okay, we are replacing it with a missing value here with pd.na. So this helps keep the email address column cleaner and more reliable, right? So now in place of invalid email address, we have na, right? Now we will decide what to do with the remaining missing values. Okay, so we have missing values in customer ID also, I think. Yes, we have NA in customer ID also, right? We have NA in full name. We have NA in age. Okay, so now now we have NA actually everywhere in this data frame. Okay, where initially invalid data was there or missing values, okay, were there, right? And now here, and next step, okay, we can decide, okay, we can write statements to perform operation, okay, on the rows which have NA, pd.na. So let's print df first. So this is the current status of our data, right? So we have this data now in data frame, okay, after performing uh, many steps, okay, after performing various steps, this is the current status of the data. So let's do something with this NA, okay, in customer ID. So here we can write df dot drop NA, drop NA, and then you can specify the subset. So subset is a parameter, subset equals to, and specify the column name. So column name is customer ID. Customer ID. Okay. And create a new copy of this data. So drop NA. It means we are dropping NA. Dropping means the record will be dropped. Right? The row will be dropped. Because this row is of no use. Because this customer ID is very important. Right? So if in your data, if you think that customer ID is very important, if customer ID is missing for a particular row, okay, then if you think that row is of no use, okay, that has no meaning, in that case you can drop that row, okay, using this statement df dot drop na, use drop na function and use subset parameter to specify the column and create a new copy and then assign it to df, okay, and run this cell. Now let's print df, and if you see this record 100 hours has been dropped, right? After C007 we have C009, so this record has been dropped, right? Okay, now you can decide what to do with the full name column. Okay, if full name, this full name has NA, then what we should do with it, right? So let's replace it with unknown string. So here we can use NA and select the column. Column name is full name. Okay, we are selecting full name column and then call dot fill NA, fill NA function, right? And then you can specify the value, okay, with which you want all the occurrences of NA to be filled. So now we want all the occurrences of NA to be filled with unknown, okay, and then we can assign result to this column, okay. So we are assigning this result to df full name. Run this cell. Let's print df, and if you see here, in place of this NA, in this last record, now we have unknown, right? So actually we are now replacing NA, all the occurrences of NA, okay, in our data. Okay, now in city, okay, we have NA. So here df and double quotes, column name, city. df.city dot fill na. Here also let's fill unknown. Okay, if city is missing, if city column has na, let's fill that with unknown. Okay, and assign this to the same column df city. Run this cell, print df, and now in city, okay, two occurrences of na and na have been replaced with unknown, unknown. Okay, now membership. In membership column we have na, right, two occurrences of na. So here we can write df, column name is membership, okay, dot fill na. Here we can replace na with unassigned. It means the membership is not assigned. Unassigned. And assign this to the same column. df.membership. Run this cell. Print df again. And membership, now we have na have been replaced with unassigned, unassigned. Right? We have na in age column also. 4 na. Okay, 4 occurrences of na. So here what we can do is, if you replace these na with the median of age values, okay, then this that will not change the meaning of this data, right? So here what we can do is we can calculate the median value of age. First of all, select the column df of age, df.age dot call median. It will give you the median, and then we can cast it to integer, numeric value. Okay, and assign it to median age equals to. So we are calculating median and assigning it to median age. Okay, run this cell. Let's print median age. Okay, to see what is there in median age. Median age value is 31. This is the median of these values. These values. Right? And then we can fill these na, right, with median age value. So here we can say df of age dot fill na. Okay, fill na and age column with median age. Okay, and assign this to the same column. Run this cell, print df, and if you see here, all na, 4 occurrences of na have been replaced with 31, 31, 31 and 31, right? Median age value. So we have worked with customer ID, full name, age, city, membership. Okay, now let's work with total spent. In total spent also we have one NA. So here df total spend, select this column, df dot total spend dot fill NA. Okay, because these are currency values, right, in this column. So we can fill NA with 0, 0.0 and assign it to total spend. Run this cell and then print df. And in total spend, now this NA has been replaced with 0, 0.0. Okay. Now we can count sum of the count of NA. So here remaining NA actually. Okay, here we can use df dot is NA dot sum. Run this cell and now here if you see in customer ID the count of NA is 0, full name count of NA is 0, A is 0. In email address we have one NA, right? And okay, in join dot also there is one NA. And in city count is 0, membership count of NA is 0, total spend count of NA is 0, right? So for this data set we removed rows where customer ID is missing because it is the main identifier for each customer, right? For the other columns we use sensible replacements, like missing where names and cities becomes unknown, missing membership values become unassigned, and missing ages are filled with median age 31, 31, 31, right? And missing spending values are filled with 0, 0.0. We still have missing values in email address and joined it, and that's okay. Sometimes it is better to keep missing values, okay, instead of forcing a value, okay, that may not be correct, right? So we can leave this NA and email address and NAT in join date, right? Now before saving this data to the final file, okay, we should check that the clean data set follows the rules, okay, we expect, right? So here let's create a final membership. So if you remember, we created a list of membership, valid membership, right? Yes, so this was the allowed list of membership, like set of membership. Copy this and so let's name it final membership. Okay, so we have bronze, we have silver, and we have gold, right? And we have unassigned also. So here we can add this unassigned, okay, to this set, because now we have unassigned also, right? Run this cell and we have created this list of final membership, right? And now write statements to validate every column, right? So here we can write df column name is customer ID, this, right? Dot. Now actually we are writing statement to validate all the values, right? So dot not NA dot all. We are writing now actually assertions. Assert. Run this cell or we can write all assert statements for all the columns, okay, in the same cell. Let's write df write uh, one more assertion for this customer ID. Df dot customer ID dot a is unique. Okay, this customer ID must be unique. So we are writing one more assertion that this customer, no two customers, okay, should have or can have, okay, same this customer ID value, right? So is unique. So this customer ID is unique and it is assertion. Assert. Now write one more assertion. Next assertion for age. So df of age. What should be the assertion for age? Dot age value should be between, if you remember, when we actually cleaned age column, email address, yes. So age, okay, so we replaced any value outside this limit 0 and 100, okay, we replaced those values with na, right? So valid age is 0 to 100. This is a valid age. So here we can write, okay, age must be between 0 and 100, right? And check this for all. And it's an assertion. Now add one assertion for total spend. Df of so we have selected total spend. This total spend value dot greater than 0 dot all. Assert. Now we can write one assertion for membership, this column, and we have already created a list of final membership here, right? So here we can write df and select membership column dot is n. Okay, so is in checks values of this column in a set actually, right? So we will check these values in a set. So we want to check these values in final membership, this set, right? And check all. Assert. And if all these assertions are passing, okay, then we can print, here we can print all validation checks passed. Run this cell. If any validation will fail, okay, then this statement, okay, will not print, means will not execute. All validation checks passed, right? There is no issue, right? Let's change this to 120. Not 120, actually check 90. Now in age we have 42, right? Okay, let's change it to 40. So here we are saying the valid age is 1 to 40, right? And there is one row where the age is 42. Run this cell again. And this, see, now one assertion failed. This assertion, there is assertion error. This assertion says that this assertion failed. It means there is one row, okay, which is not actually meeting this criteria, which is not passing this check, right? Because in one record there is 42 value and we are saying that valid value is 1 to 40, right? So this is how you can write assertions, right? So here we can write 100 because for us 100 is the valid value. If you run this, all validation checks passed, right? So these checks helps us confirm that the important cleaning steps are worked. We are checking that every customer has an ID, customer IDs are unique, ages are valid, and total spend is not negative. And membership values are only from the final approved list: bronze, silver, gold, and unassigned. If all checks pass, okay, we can feel more confident using this clean data set, right? So now we can review the final result. Okay, we can review the clean data set and make sure everything looks correct. So here we can print this df again. Okay, df dot head and n equals to 10. Okay, we are using n equals to 10 because we have only 9, we had 9 rows, right? Here, see, so you can check all the data. Okay, if you are satisfied with the data, okay, then you can uh, save this data, okay, in a CSV file. So in final step, okay, now we will save this cleaned data set and in a new CSV file. So to save this final data in a new CSV file, you can use df, the data frame name, whose data you want to save, dot to CSV. Use to CSV function. To load data, we use read CSV. To save data, we use to CSV. To CSV, right? And then we can specify the file name. So let's name it clean customer dot CSV. This is the file name. Okay, so this data will be saved, this final data will be saved in a new CSV file with this name, clean customer, right, dot CSV. And index equals to false. And date format you can specify date format equals to, now you can specify the format, okay, in which you want the date values to be stored in the file. So we want y and then month and then date, enclosing this in double quotes, right? So this is year dash month dash date, right? So let's make it readable. Okay, so we have 3 parameters. We are using 3 parameters. Okay, first is the file name, second parameter we are setting index to false, and third parameter we are specifying the date format. Run this cell. Okay, cell executed successfully. Okay, now we can actually check this data. Okay, we can load this data again. So we can say df1 equals to pd dot read CSV and specify the file name. This is the file name. we are loading it again to just to verify it, right? And this time we are naming it df1. Okay, so till this step we used df, okay, because we had data, okay, in df data frame. And now print df1, and if you see, this is the final data, right? We saved this data in this file, clean customer csv, and this is the data we loaded from the same file, right? So this is a good practice to save this clean data set as a separate file so that the original CSV file stays unchanged. Okay, because you can always go back to the raw file if something goes wrong or if you want to apply a different cleaning approach, okay, later on. Right, so we have completed this data cleaning process